Hello, this is Marco Flag. I'm Marco Flag of Desert Star Systems, and this is the first in a series of short videos about OASIS, which is Desert Star Systems' new open acoustic software integrated system, a kind of contorted acronym for what might be better described as a software-defined acoustic radio. These are all single take videos. I'm just trying to keep them short and efficient. So I'm going to misspeak here and there and correct myself. Just take it as it is. Again, the point is not on prettiness, but on efficiency with this. This will also go together with these videos with documentation that we have on our GitLab site, and you will get a GitLab account as a user of OASIS. And I'll briefly show you that here, how to get to that. Let me end the slideshow, and here on my browser window I have GitLab here, and here's like one of the chapters here about the low frequency receiver, which I'll discuss in one of these videos. To navigate around it, well, to find it, you look for a wiki here on the left bar, and then to navigate around it, like here we are in 3.2.1 low frequency receiver. How I got to there is I hit 3.0 hardware, and then 3.2.1 low frequency receiver, and here we are. There we are. Okay, so with that, let's do a brief overview of what OASIS is about. So I'll do this slideshow here. Okay, so as I already said, it's sort of a software-defined radio architecture, however, one that's specifically optimized for underwater acoustic applications. They're quite different from radio applications. Frequencies are much lower in underwater acoustics, but you also have things like you need to be able to drive sonar transducers. They're very high impedance devices, and you have to develop, several hundred or even thousands of volts. So it's optimized for that. It's optimized for very low power consumption. And you can do a number of things with it. Here are some example applications. The first five I'm mentioning are actually current active projects, all of them either done by Desert Star or done by one of our customers. Specialized acoustic modems is one use case for it. Also underwater acoustic navigation and tracking, so you can precisely time the time of arrival of acoustic signals, and that helps you implement navigation and tracking applications. How about a multi-manufacturer deck box for acoustic releases, specifically for fisheries inspectors and ropeless fishing, so they can have one deck box that can trigger releases from uh, many manufacturers, all in their own underwater acoustic protocol. Now then we have two applications that relate to precision acoustic time synchronization of underwater devices. If something needs to happen at several locations underwater at just about the same time, for example, that would be one application for this. Signal monitoring and reporting. There's an active project for detecting the presence of whales, but it could also be boats, ROV, UUV, divers, for things like protecting underwater infrastructure like pipelines and underwater cables, for example. And there are many more possibilities. So OASIS as an architecture can actually run on multiple platforms. Here we are looking at the board level. This is a board called the EM60, and here we will see that showing up in a lot of our videos. It's 5 inches long. The width of it is, what is it, an inch and a half or something like that. And then it's sitting next to this thing, which is like a payload section for a satellite reporting tag. You can see it's all potted. It's a very, very tiny implementation of OASIS. Here is a ceramic resonator for broadband detection of signals. This one can transmit and receive. This one can only receive. These boards are then integrated into various boxes and devices. Like here we have a deck box with an over-the-side sonar transducer. You can see that here. a multi-frequency band sonar transducer. It's going over the side. That's for the multi-manufacturer deck box or pressure housed modems. And then here, a potted device. Here is an Argos satellite transmitter and a whole solar power supported data processing system and data archiving system. Whoops, I went over to the next slide already. And you can see that this acoustic, what we call payload section, is integrated here in the back. It just plugs in. It's a plug-in payload section. Something like that can sit on the seafloor, for example, and listen for signals of interest and then pop up to report. There's a pop-up mechanism in here as well. OASIS supports user programming. So in that sense, it's an open architecture. You can develop your own applications. Here's a snippet of code. This one here is actually in C, but what you'll see is it's in C++. The whole API is in C++. So if you're proficient with that, that's how it works. And finally, some summary characteristics. I talked a bit about minimal power consumption. That, of course, enables long battery endurance. So if you imagine an 18650 lithium battery, they are a little bit larger than a double A battery. They are used, for example, in vaping for smokers. And that can support, acoustic data acquisition and DSP processing for 2 weeks on just a single double A. So you can see with a larger battery, you can just get into months and years of service. It's software-defined OASIS, programmed in C++. We went over that. It's open. That is, you can, using an API, really greatly simplifies how to use this platform, and you'll learn a bit about that in the overall software development kit. So you can do your own development, and of course, we're using it at Desert Star as a foundation architecture for a bunch of new products as well. Many hardware platforms, from thumb size to some that are not here yet, even larger than this one. This one can go onto a motherboard, or will go onto a motherboard to give you very high acoustic transmit power, and some other characteristics like GPS on there for some calibration of oscillators and so on. It's very wide bands. You can do useful work to below the 100 hertz range, probably down to 10 hertz or so. And you can go with limitation above a megahertz even. Then finally, there are versions for defense. That's how it started out in DARPA SBIR. They are ITAR/CUI classified, so there's some restrictions, and also commercial versions for just commercial and scientific researchers. It is an SBIR product, a Small Business Innovative Research Program. So we developed that in phases 1 and 2. That makes it eligible for federal sole source procurement under the phase 3 rules. So if you're working in the federal government, that simplifies your procurement. All right, that's the end of the first video. I hope you enjoyed it. Look through the other ones and use them in combination with the documentation on Git, and we hope you can get a good start with that. Thank you.